Okay, first we end up resetting the machine. So we hold up the stop, hit reset a few times, now it resets the machine. And we have to put in the initial address where the program, the bootloader, is going to be loading. Bootloader loads at the top end of this memory page. It's a 8K memory page, so it's a pretty small chunk of memory that we're actually able to use because this is an old computer. So we go ahead and examine that, and you now see that this memory is taken from the sense switch, put into the address bus. Right now we have this data in that memory location. Now we need to actually update that data to end up being the first part of the bootloader. We go to 1111 and hit deposit, and that will now deposit that first instruction into that memory location. Now we're going to look at the next memory location. That doesn't have what we need in it. We need 1000 in there, and so we'll now deposit that in there. And that's how did you end up doing that. If you end up having to go back to the start or something like that, and we'll go back to the start, put in the address and the sentence lines where you need to go back to, hit examine, and now you'll see that you're back to that address. And that doesn't, that address. So lots of switches to keep track of, and lots of switches and data to put in, but after a little while you get it all in there. Okay, now my whole program is keyed in, and now we can check the program. So I'll set in the start address, hit examine, and then each memory location should have each piece of code in it as we examine the memory. Then I'll examine the switches again, and now we can go and do single step of the program, make sure it's not going off into the weeds. So what I look for in that is just to make sure that we never leave this memory page as I hit it a bunch of times, and it's going to just kind of go around in the loop checking for activity on the COM port. So as long as it never really goes out of that little program or segment, we're okay. So now we hit run, and the program is running. You can see this LED A4 is a little dim because it's one of the higher order addresses as the program runs. Now we go over to the laptop. I'm running real term on the laptop, and I've set it for a larger font. We need to set the parity and the data bits, and the parity is none, data bits 8, stop bits are 1. And now I can go and send the actual file. Now I've set up a serial monitor right here, and it's transmit and receive LEDs. I'm ready to send the file. The file is 8kbas.bin, and that is an 8K basic for the Altair. And so I'm going to hit send file. It has 0 delays on any of the characters, so it's going to go in very quickly in a matter of a moment. You can kind of see the A6 and A5 flicker, but maybe not on the video. But that's because it's sending the file very quickly, or writing very quickly to the memory location, so a long time between writes. Anyway, it's in, and so the next step is to go over here, key in start memory location. I'm going to hit stop so that the processor stop. I'm going to hit examine memory location 0, and then I'm going to hit run. But when I hit run, I'm going to be looking over here because you're going to see the prompt. Memory size. So I hit enter. Terminal width, enter. Want cosine, tangent, and such. I generally say yes. That does take up more memory though. So if you have a Yeah, if you have a non-trigonometric program, you're all set. And as you can see, it's booted and ready for program input. To send the program, I end up having to change our port settings. The port settings now need to be space 7, 1 stop bit, and change that. I'll now go to the send, and when we're sending, now we have to have a 4 character delay between the bit, or 4 millisecond delay between the bits, and a 1500 delay on the lines. And the reason for this is it gives Altair enough time to digest the lines. Some of the lines it'll digest quickly, other ones it'll not. But we'll go ahead and send the file. The file is going to be craps.bin, and we'll send it. And it takes quite a while to go down at this rate, but it's the safest way to get it in. You can probably tweak it to be a little more efficient, but this is what I started with. And here goes the file. It's going in, and as it goes in, you'll see Altair digesting it over here. Here you see the activity of the send and receive characters over here on the serial line, and a bit of a glow on the LEDs. And when you get into a long line, you'll notice that the LEDs do a very long glow. You get into a short line, they don't. And it depends on how long it takes it to interpret the line and translate it into tokens in the memory. So this will take a while. Okay, now the program is all in, and I'm going to do a list of the program, list, and we'll see that it has, it's in the Altair. You can see the Altair doing its thing. I'll relist it here. Doing its thing while it's listing, pulling it out of memory, making it readable. And so it's over here, ready to go. So now I type run, and it's running. Unfortunately, I need to expand the display a little here. Okay, do you know how to play? Yeah, I've played this before. My name is Don, and I want to try my luck. Yes, and I'm going to do. And so, as you can see, things are doing pretty well. I'm about 1,000, and I threw a 7, so I won 1,000. So, as you can see, the machine runs, and you can use the 8K memory board to play things with the 8K basic, or the 16K memory board to play the 8K basics. So, it's a good machine. It's run well. I've let it run for a few hours, and it's done pretty well. Never seen it crash, so I think it could be reliable for anybody that wanted to add any expansion boards and maybe bring it up to full capability.